Hi everybody, today let's look at how do we solve simultaneous linear equation using matrix method. First, we have to know how do we write a pair of simultaneous linear equations into matrix form. For example, if you have a pair of simultaneous linear equations, ax plus by is equal to e, cx plus dy is equal to f. So how do we write this into matrix form? It's actually pretty easy. You write a big parenthesis and two smaller parentheses. Okay, that's why. The next step, you just look at their coefficients. But before that, before you write them into matrix form, make sure you arrange the equations nicely. X, y, and the constant on the other side. Okay, now you just look at the coefficient here. Okay, so I think I will just highlight also together with the positive, because if this is a negative, when you write the element, you have to write negative as well. Now A, you write A. Positive B, you just write B. C, you write C. Positive D, you write D. And this is for X, Y. And the last one is E and F. So this is a way how we write the pair of linear equations into matrix form. But why do we need to write this way? Why cannot we write A, B, C, D, right? Now, we try to do the multiplication between these two matrices. See what we will get. I hope that you still remember the process. This is 2 by 2 matrix, and this is 2 by 1. So we know that our answer must be 2 by 1, right? It means 2 row, 1 column. Okay. Now let's do the multiplication between these two matrices. Draw a horizontal line for the first matrix, and second matrix we draw a vertical line. First row, first column. Now I'm going to calculate the element for first row, first column, which is here. A times x, ax. B times y, by. Okay. Now let's proceed to the second row, first column. Second row, first column is over here, not here, right? So we have to write over here. Cx plus dy. Cx plus dy is equal to EF. Now, you will get back this linear equation. Ax plus by is equal to E. Ax plus by is equal to E. Cx plus dy is equal to F. Cx plus dy is equal to F. That's why we write this pair of linear equations in this form. Okay? Now, let's try a few examples. Write the following pair of simultaneous linear equations in matrix form. So remember, before you write them in matrix form, make sure you arrange the linear equations nicely. So this is already arranged nicely. X, y, and the constant are on another side. So we can start change them, writing them into matrix form. One big parenthesis and two smaller parentheses. Okay. Now, 2 positive 4. We just look at their coefficients. 2 positive 4, you don't have to write the positive, you just write 4. 5 negative 3. Remember, you have to write a negative. And then x, y. 4, 10. Okay, so this is a way how we write this pair of simultaneous linear equations in matrix form. Okay, now let's go to part B. So this one, you will notice that the linear equation haven't arranged nicely. So what we need to do is first thing, rearrange the terms. So this, let me copy down first. X is equal to 2y plus 8. So I bring the 2y over here. X minus 2y is equal to 8. This is the first equation. Now let me move on to the second equations. Y is equal to negative 3x plus 6. I bring the 3x over here. It becomes 3x plus negative 3x. Bring to another side, it becomes positive 3x plus y. Nothing here, it means plus. Is equal to 6. This is the second equation. Okay. Let me write the second equation over here so easier for you to see it. 3x. So this is 3x plus y is equal to 6. Second equation. Now we have arranged all the terms nicely. We can start to write them into matrix form. One big parenthesis, two smaller one. Okay. Now just look at their coefficients. The x here, you see nothing in front, the x, that means it's 1. You have to write 1, not 0, okay? Be careful. The coefficient here is 1. This is negative 2. 3. Nothing here, it means 1. Positive 1. But you don't have to write the positive sign, you just write 1. And then xy. xy. 8, 6. Okay, so this is the way how we write this pair of simultaneous linear equations in matrix form. Now let's try a few more other examples. We need to learn in this part, the main thing we need to learn is how we solve this simultaneous linear equation using matrix method. Okay, now we are going to learn it here. Find the inverse matrix of this. Okay, I just let A be this matrix. Negative 1, 3, negative 2, 5. The inverse matrix of A is 1 over negative 1 times 5. You will get negative 5. Okay? Minus 3 times negative 2. You will get negative 6. Okay, so this is the determinants of matrix A. Next step, we swap their places for these two elements. 5 go up, negative 1 go down. These two elements, we change their sign. 3 will become negative 3. Positive 2 will become negative 2 will become positive 2. Okay. So this is negative 5 plus 1 is equal to 1. 5 to negative 3, negative 1. Okay, so the inverse matrix of this matrix is 5, negative 3, 2, negative 1. Now let's go to part B. We want to find the matrix PQ if this matrix times PQ is equal to 2, 1. Let me copy down this one first. Negative 1, negative 2, 3, 5. PQ is equal to 2, 1. So if I give you an equation, for example 3x is equal to 6, I ask you to find the x, the value of x. I think majority of you will be no problem, right? X is equal to 6 divided by 3, which is equal to 2. But the problem is this is matrix. We cannot take this one divided by this. So what we need to do is try to do something to get rid of this. Okay. Do you notice that this is exactly the same as this one, right? So I will just change this to A. Then PQ is equal to 2, 1. If I want to get this matrix PQ, that means I don't want the A. I want to get rid of this A. So how do we do so? We multiply both sides by the inverse matrix of A. So whatever we do for the left hand side, we do the same thing, exactly the same thing for the right hand side. Still the same, multiply the inverse matrix of A. Then let me copy this, is 2, 1. So what will happen here? When you take A inverse multiplied by A, this will eventually give you identity matrix. Okay, here I will just copy. And still remember, identity matrix is just like 1. Identity matrix, you times PQ, you still get back PQ. Okay, finally, we got the PQ, right? So we just do the multiplication between these two matrices and we will be able to get PQ. So in the exam, actually, you don't have to write this way. This is just for explanations. So in the exam, you can do it this way. Now I know that I want to get rid of this. I need to multiply both sides by the inverse matrix of this matrix, right? But I also know that when I multiply the inverse matrix for this side, this will actually become I, so I don't have to write it. So I will just write PQ. PQ. And here I will write the inverse matrix of this matrix. So which is this one? 5, -3, 2, -1. And don't forget to copy this. 2, 1. Okay. So PQ is equal to, this is 2 by 2. This is 2 by 1. We know that our answer will be 2 by 1. 2 row, 1 column. Five times 2, you will get 10. -3 times 1, you will get -3. Now let's move on to the second row. Second row, first column. 2 times 2, you will get 4. -1 times 1, you will get -1. Okay, so PQ is equal to 10 minus 3, you will get 7. 4 minus 1, you will get 3. Okay, so PQ is 7, 3. This is the way how we get this matrix PQ. Let's try one more example. A shop sells two types of mobile phones. So we have brand X and brand Y. So we have brand X and brand Y. On a certain day, 5 units of brand X and 3 units of brand Y were sold. On the second day, 7 units of brand X and 4 units of brand Y were sold. Total sales for the 2 days were 700 and 9700 respectively. Find the selling price of each brand. So I just let the selling price for brand X be RMX. The selling price of brand Y be RMY. Okay, now I'm going to form two linear equations first. For the first day, 5x plus 3y is equal to 7100. 5x plus 3y is equal to 7100. Okay, this is the first equation. And the second equation, 7x plus 4y is equal to 9700. 7x plus 4y is equal to 9700. So we have the second equation. Find the selling price of each brand. So here I'm going to show you how do we use simultaneous, how do we use matrix method to solve this type of equations. A big parenthesis, two smaller one. So before you write them into this form, make sure you arrange all the terms nicely. X, Y, Y, and the constant on the right hand side. 5, 3, 7, 4. 5, 3, 7, 4. And this is X, Y. 7, 1, 0, 0. 9, 7, 0, 0. Okay, so we know that if we want to get rid of this, we have to multiply both sides by the inverse matrix of this one, right? So here I will just write X, Y, and I'm going to write the inverse matrix for this matrix over here. 1 over 5 times 4, you get 20, minus 3 times 7, you get 21. And then these two elements, we change their places, interchange their places. 4 will go up, 5 will go down. 4, 5. And these two elements, we change their sign. Positive, it becomes negative. Positive, it becomes negative. And don't forget to copy this. 7100970. Okay. So this will equal to negative 1, 1 over negative 1, 4, negative 7, negative 3, 5, and here will be 7100970. Okay, so this will give you negative 1, right? What we need to do, negative 1 is multiply inside here, all the symbol here change. Positive, it becomes negative. Negative, it will become positive. Because negative 1 times 4, negative 4. Negative 1 times negative 3, you will get positive 3. Negative 1 times negative 7, you get positive 7. And negative 1 times 5, you will get negative 5. 7100 and 9700. Okay, xy is equal to, now we just do the multiplication between these two matrices. First row, first column. Negative 4 times 7, 100. Okay, you just press your calculator. Negative 4 times 7, 100. Negative 28400. And 3 times 9700. You will get positive 29100. Okay, let's move on to the second row. Second row, first column. 7 times 7, 100. You will get 4. Oh, let me use back blue color. 49700. And then negative 5 times 9700. Negative 5 times 9700. You will get negative 48500. Okay, we are almost getting the final answers. Negative 28400 plus 29100. Here you will get 700. And this part, 49700 minus 48500. Here you will get 1200. But until here, you still cannot stop here. You need to answer the questions, the selling price of X and the selling price of Y. So I'm going to write here. Selling price of brand X is equal to 700 ringgit, and the selling price of brand Y is equal to 1,200 ringgit. Okay, so this is our final answer. This is how do we solve simultaneous linear equation using matrix method. Let's say if you want to check your answer by using your calculator, you can do it this way. You can just use simultaneous linear equation function. So for example, you go to this, your calculator, go to equation and simultaneous equation. Now we have two unknown, right? As you just press 2. Now just key in all the coefficients here: 5, 3, 7, 1, 0, 0. 5, 3, 7, oops, sorry. 5, 3, 7, 1, 0, 0. And then 7, 4, 9, 7, 0, 0. 7, 4, 9, 7, 0, 0. Okay, then press equal again. You will get the answers. X is equal to 700 and Y is equal to 1200. Okay, so if you don't want to use this function, you can actually use matrix function as well. So what you need to do is, okay, let me clear this one first. Now I go to matrix. Okay, I'm going to enter this matrix and this matrix. I will just set this as matrix A. I'm going to define it. You have 2 row, 2 column, 2 row, 2 column. So 5, 3, 7, and 4. So this is matrix A. Now I'm going to define another matrix, matrix B. So now I have 2 row, 1 column, 2 row, 1 column, 7, 1, 0, 0, and 9, 7, 0, 0. Okay, now I have 2 matrix on our calculator now. Now I just want to call out the matrix that I have just keyed in just now. I want to take the inverse matrix for A times the matrix B, right? Okay, press options, go to matrix calculations. Now I want to take the matrix A, press 3. Since I want the inverse matrix of matrix A, I have to press this. This means the inverse matrix of matrix A time matrix B. This one. Option matrix B. Okay, then press equal. You will get the answers 700 and 1200. Okay, that's all for this video. Thanks for watching. See you next time. Bye bye.